to solve this, you're like, well, maybe it's reasonable that scope is local for a function as well, right? So here, you do the same thing. Right? You're like, once you've seen the ID, for either one, scope's going to be local. Does this fix our problem? Diana?
I'm not really answering the question you just asked.
Good.
But inside the non-terminal marker, could you do like an if with a look ahead? So you know which one you're in, and then you know.
So you're saying, could I do if the fourth token from now is a semicolon? No. That would be awesome. But see, the problem with that is, so it's kind of it's a really intuitive thing to be like, well, if I could just look a little further ahead, I would know which one of these rules to do. I could solve my conflicts that way, right? The problem is that rabbit hole never ends, right? You could give yourself 4 tokens to look ahead and make your table really complex and make your grammar really difficult to understand. But then I could make a rule that you need 5 tokens look ahead, right? So you're like, fine, you counter and you make some sort of machine that can look 5 tokens ahead. I'm like, well, now you need to look ahead 6, right? So it never ends. I mean, that would solve this, but it wouldn't solve other problems. So what we want to do is try to use our 1/0 tokens of look ahead and actually still parse with it. So does this look good? Yeah, Eric.
Well, do those 2 code blocks refer to the same marker?
Good question. So he's asking, so I've written scope as local, right, as a semantic action, and I've stuck it in the middle of this code. Does Yak actually associate these with the same non-terminal marker? And the answer is no, right? So now we've changed our problem to a reduce-reduce conflict, right? So now it doesn't know, well, should I set scope to local and go here? Or should I set scope to local and go here, right? So that's rough, right? Because, I mean, we know that those are exactly the same. You could code the M1. That's exactly what you have to do. So instead of actually putting semantic actions in the middle, what you'll do is you'll write M1 as I've written it on the board, the way Yak somewhat does it under the hood. And then here, instead of putting actual curly braces, you'll just put M1 and M1. And now it knows, I mean, they're obviously the same. They're the same non-terminal, same reduction. So it reduces and it goes along just fine. So if you were to have, if you're not using this M1 that we've written, right? If you have a grammar that's just the curly braces in the middle of a rule, and you go to your y.output, it's actually, you'll notice that it actually does make an M1 for you. It'll actually have a whole nother state, and it'll make a whole new non-terminal called like $$1, adds like an extra $. And so you can look through your y.output that way. How does this make sense?
Sort of, but are we actually going to need it?
Yep. So I mean, this is kind of a odd example, right? So let me construct one that'll be more meaningful. So let's say you have some rule. I'm not going to call the left side. I don't really care, right? But it's a while, right? Parentheses. I'm not going to put quotes. Going to lie to you again. Expression. Statements or something like that, right? So when we're doing code generation, right, actual like semantic analysis and actually doing something with this, if at the end of this, right, and let's say this reduces to, I don't know, like a statement, a while statement, I don't know. If only at the end we do some calculation, right? I don't know, maybe like solve expression, right? If $3, you know, do something, right? It only happens after it's finished, this whole rule, right? So there are things that you have to do at the beginning of like a while block. Like what you're going to need to do is probably have some sort of mini activation record type thing, right? That's going to set up a block here, right? And actions I do in this block shouldn't necessarily affect actions I do outside of the block, unless we have like similar, like the same variables, right? And I should only actually like execute code for this if the expression was true and whatnot, right? So along the line, you can't always just have your rules at the end. But it's also probably a bad idea to just put this in the middle of your code. So what you're going to want to do is have these. You shouldn't need this at all for the assignment that we're doing right now, the one that's due Sunday. This is just a warning. I don't remember. Does the next assignment start this Sunday? Or do you guys get a break for like a week? Break? Okay. Oh, that's right. You guys have a midterm, right? Right. So you'll have a week to kind of think about this. So with this being stuff that we're going to do, like after the midterm mostly, you guys have a project due in 72 hours or something. I figure we can talk a little bit more about that. Are there any like glaring questions that people have right now that they'd like to pose to the class? The wonderful thing about talking here is that a lot of you are smarter than me, so you can answer each other. But everyone's already finished, so it's not a big deal. All right, cool. So a couple little things. There's been some confusion on when we're in the parser and when we've written, Dr. DeBry has written online in the B and F, you have something like this, right? What does that mean, right? They're like, does the scanner give them that? Like, how do they get this strange quote, parentheses quote? So essentially what this is, in case there's any confusion left, is you're having the scanner not actually generate a token, right? You're just returning this instead. I mean, like, it's effectively a token, but you're not doing that whole integer value associated with it. You're not defining it and whatnot, right? It's just a single character, so, I mean, there's no real reason to do anything special with it.
This isn't actually true with that. It's a question about the error function that Yak has built in.
Okay.
So I was doing a little reading on it, and it, I guess if it finds an error and then 3 normal tokens, then it'll continue to parse normally. But if it finds an error and then an error, that'll collapse the program, or I'm not exactly sure what the behavior is there. It seems like I'm going to be using it. Well, what does error do in that case? Does it just stop parsing and go, oh God, no?
So if it sees 2 errors in a row,
Right.
that should behave kind of like we were looking at earlier, where it kind of gets lumped into one giant error. So it won't successfully, so why error, when it enters the error state, it throws this error, right, and then it tentatively starts up again. It's like, well, if I can shift 3 things in a row successfully, then I'll think things are good again. But if I can't do that, then I'm going to stay in the error state, right? This is so that it doesn't report like 12 errors for the same error, right? Because if you've just misspelled while, you don't want it to give you an error on the while, and then an error on the parentheses, because it's like, well, I don't know what this parentheses is doing here, and then an error on the expression, because it's like, why did you have an expression in the middle of nothing, right? And then an error on the right parentheses, right? So what it's trying to do is like, well, if I can look ahead, you know, and kind of go, I shouldn't say look ahead, because it's not look ahead. But if I can consume a couple tokens in a row, then I'll be like, well, okay, I think I can find myself back in the state machine. It'll find its state and try to continue.
Okay.
Right.
Okay, there's like YY error, YY text, and YY val, but I kind of get what those do. Are there others, like YY whatever?
Yeah.
Can you explain any of them that you know that might be useful?
So I mean, we've talked about YY error okay, right?
Yeah.
And that's very relevant to what Eric and I were just talking about, right? Where if you tell it you don't need to shift 3 tokens, just jump right back in. I don't actually know a whole lot of other ones. I mean, like I've read them before. I don't use them. They shouldn't be particularly useful for you. There's one that's like YY clear in that like I think clears the stack, so it essentially tells it to start over from this point. I'm sure there's a couple others, but I don't know about all the YY functions.
Do we have to set YY val? Because you said something about using YY val with the dollar sign thing to work on the error.
So at this point in the assignment, you may realize that you don't actually need YY val, right? You never compute any dollar signs. You're not making a calculator that does anything, right? If we were to compare this to the calculator, all that your program is doing is making sure that I have a syntactically correct expression that I'm trying to solve. It doesn't solve anything, right? So at this point, no, you don't need YYL val, right? You could report tokens rather than lexemes.
Okay.
There's really no use for the YYL val at this point, I think. Am I wrong? You look at me like I'm wrong.
No, I'm just curious. Is it okay if we report lexemes instead of tokens?
Yeah, personally, I think it's better, right? Because, I mean, especially because, like, what if your naming conventions for tokens are different than I would have, right? So that vaguely brings me back to this. So I have what Dr. DeBry has told me is a bad practice in writing parsers and scanners. So don't do this, I guess, but you can if you want. It works just fine. So I don't like these. These like not quite tokens, scanner just kind of gave the parser something, the parser deals with it, right? They look strange to me, and I kind of like everything to be tokens and non-terminals, right? So when I write my scanner, I say, hey, if you see a left paren, right, return a token called left, or left paren or something, right? And then Yak and Flex will team up to assign this some integer value above 268, right? And when you write your code, you just use left paren in all caps, and it looks like a token and it makes sense rather than this. So this is longer, right? And it adds nothing to your code. It doesn't help it at all. But it makes more like intuitive sense to me. It's easier for me to get in the motion like this. Brian?
If you didn't do it that way, you don't need anything in the lex file for that. Is that correct?
Right. So it should just return it.
Yeah.
Or you may need to put quotes around it or something. I'm not sure.
In the lex file?
You may need to, yeah. You may need to, because I mean it looks like this. I'm not sure.
Okay.
See, because I do it this way, so I don't really know. So both are valid. Dr. Breyer would like to recommend against this, but I think it's prettier, so I will counter with you should do it. Yeah?
How did you get the first one to work? Because I tried doing that at first, and I couldn't get it to work. I kept getting weird errors.
Who's done it? How do you get it to work?
I still had to enumerate all the different little things like that in my lex file and return them as YY text. Kind of like in the calculator when we had anything that's not a letter or digit.
Mm-hmm.
We had a set for that, and then we returned just YY text itself instead of a token. That's how I did it.
Okay.
Use the calculator example.
So you don't actually use the return statement?
No, you still need a return statement.
Oh, but you're just returning the YY text value instead. Oh.
Yeah,
So-
I just took it straight from the calculator example.
Oh.
Quickly for the camera, I'll repeat because I don't know how well you guys hear each other online. But the question was, how do we get this to work? How do we actually get flex to return just this left parentheses, and you actually have to make a rule for it. You can enumerate this or have, you know, the dot or something like that, and actually return YY text in the scanner. Keith, yes? Okay.
Isn't that kind of like doing the same thing as using parameters?
Yes, I mean, it's very much the same thing, right? I mean, the difference is that this is YY text and this is a number, right? This is a pound define. And the difference is I like this and DeBry likes this. But, I mean, you're not going to get docked points for either way. They're fine, they're valid. I don't know. Yeah, they're the same. Other questions before I move on to the next thing? So I won't call names and whatnot, but so Bacchus Noriform, as it is online, has some kind of standards that make it look pretty to read, but don't work in Yak very well, right? Take, for example, this is a really common one that I'm seeing. Anyone worked with binop? You know, like that's a plus, a minus, divide, or a times, right? And so you work really hard, and you're like, well, I have all these shift-reduce conflicts, right? But I remember Sam's awesome lecture on calculators, and so I'm going to define precedence and associativity for these, and also the logical operators down the line, right? I'm going to do that. All right. So you do that, and then you continue, right? And you have up here, you have an expression, binop, an expression, right? And you're really excited, and then you yak, and it tells you that you have 64 shift-reduce conflicts. And you're like, Sam lied to me. He told me associativity would solve this, and it clearly has not, right? Has anyone encountered this? Woo! Exciting. All right. So I know that I've talked to a couple of people about it. Sorry, I just got distracted by how crooked my writing is. Look at that.
You don't even notice.
All right, cool. Is anyone who I guess I haven't talked to, because I've just explained it to some people, does anyone know why this all goes to hell? I'm calling Will in the back.
I just kind of realized that when it decides to reduce,
Mm-hmm.
it's only got those 4 tokens to reduce to, and so it's not using the expression rule to decide, oh, well, binop has an associativity of this whenever it uses this.
Mm-hmm. So he's saying that when you reduce these to binop, the expression doesn't actually, you know, you could give binop.
Binop doesn't have a precedence.
Okay, so binop doesn't have precedence. That's good. So I misheard you.
Well,
Okay, so Will's saying that binop doesn't have a precedence. And I counter, well, fine, declare a precedence for it then, right? Why don't you do that?
have the number of precedence, plus, minus, divide, times, precedence.
Good, good. I've heard both the reason and like the explanation for it. Really good. So this is a non-terminal, and you're like, okay, so it's a non-terminal. These are terminals. I want to declare precedence for these things, right? So you know, well, I can just tell you that Yak doesn't let you declare precedence for non-terminals, and you can go home. And you can be like, oh, all right, I guess I'll just go with that. But to basically understand it, you're like, well, it makes sense for these to have precedence, right? Like, we've seen how that works. But let's say I want to give binop a precedence. Who does it inherit precedence from, right? Does it get the pluses precedence? Or does it get the times precedence? Right? Like, those are very different. And so when I say E binop E, one of those is a plus and one of those is a divide. And it can't inherit both of those precedences. So it inherits neither, right? So it says... So it could inherit the smallest one. That's an idea, right? But, I mean, what would that do for us? Nothing, right? It would just, I mean, it would continue to not work. We just have a bunch of conflicts again. So you could do something probably really complicated to separate these these binops into which ones have precedences and restructure your grammar in a really obscene way, right? Or you could just kind of go the lazy way and say, well, fine, E plus E, or E minus E, right, and down the line. Like, well, We've done that before, and we know it works, so let's just do that again. Right? And now when you declare your associativity and your precedence for all those operators, it's fine. They're tokens. Right? You don't have an issue with it. Does that make sense?
That works really well in small numbers of binaries.
Huh?
That works really well in small numbers of binops.
So Brian is sarcastically saying that this works really well for small numbers of binops to suggest that it wouldn't work for a larger number.
Oh, no, it would. Take a bunch of lines.
Right. And now I'm going to counter with, well, you had those lines anyway. Right?
Okay.
So
What if you need to use like E binop E or like Q binop Q or something?
So he's saying, well, what if you had another rule that's like Q binop Q, right? So you wanted to extrapolate from that. I mean, yeah, you could just do the same thing explicitly for Qs. You could probably have, you could probably do something like an A could be an E or a Q, right? Did we say Q? Yeah. And then you could say A binop, you know, A plus A minus A, and so down the line.
Yeah, I guess that does work.
I don't think that has any conflicts, but, you know, try it out and see what happens. Eric?
And also isn't the source of the shift reduce conflicts not the E binop E, but the fact that we have binops, logical operators, and the third kind that I named?
Relational operators. So he's saying, is really the problem that we have E binop E, or is it the problem that we have binop, relational op, and logical operation? The problem actually is, I mean, it stays with this. I mean, for just this reason, where you're like, well, if I have E plus E times E, right, the kind of the canonical example, this ends up being E binop, E binop, and E, right? And once we're here, we're like, well, which side do I reduce first? I don't know, right? So it hits the same problem. So lastly, in our last couple minutes together, I'm pretty sure we've done this before, but just to reiterate. So you see something like a program is curly braces dec. This is in the BNF online, let's say. Right? Obviously, this isn't exactly what it says. Does everyone still know what the curly braces mean? 0 more. Good. Right? So 0 to many. All right? And how do you make this actually happen in Yak? Right? Because you can't just give it curly braces, then it's going to think it's a semantic action with an epsilon rule, right? And that doesn't make any sense. So there's some work in translating from BNF to Yak format, right? So you do, I mean, you make some sort of piece. You're like, well, a program is a program followed by a declaration, or it's nothing, right? Oh, good, yeah. I don't trust them either. So these are the same, right? And so whenever, I think I've done this before, and whenever I show you guys, I always just show you the really basic case of just having one thing that you want to repeat, right, and it's all alone. But the same rules generalize. So, you know, if you have declaration, you know, a program is a declaration followed by some stuff, right, you can do the same types of things. Right, so maybe you have a
program and declaration and stuff, and then you have like some other thing that's not, it's also with curly braces.
Uh-huh.
You have to break it apart, like assign different things for that declaration and to.
Absolutely. So if you're in something like this, way over there on the side, you need to kind of break it apart, and you need to have, well, there's some recursive piece, right, that does declaration, and there's some other recursive piece that does twos, and there's another piece that is just stuff, and you kind of connect them all together to one big rule. Does this make sense to everyone? We're kind of out of time, so if you have any questions on it, feel free to drop by.